Wednesday. I almost forgot what day it was for a second. It's Earth Day! Happy Earth Day. If you have a chance, I don't know, just either look outside the window or take a walk with a mask on, because officially now in San Mateo County you have to wear a mask to go outside. Or just spend some time, if you have an indoor plant or a backyard, spend some time just kind of, I guess, just focusing or giving some attention to, part of the world that is natural and, organic and green. I think it's nice to kind of take some time to just think about the ways that our planet is just so good to us, and what we have to be grateful for like how our planet provides for us. Anyway, so happy Earth Day, and new friend, dinosaur. Also, the Lyrid meteor shower, it's happening like right now. It's the first meteor shower of spring. The peak of the meteor shower was yesterday, so I tried to look out my window. It's kind of hard because there's a lot of light pollution where around me, because I live kind of near a busy street, so there's a lot of post lamps and light on all the time. But it's still going on, so you can try to check outside tonight. I can put a link in the description that kind of helped me. It kind of laid out a schedule, at this time o'clock, you should be able to see it in this direction, this many degrees above the horizon, and stuff like that. And I actually saw one. It was pretty hard to see because there was also a lamp, outside lamppost, whatever, shining in my eyes. But if you live somewhere that's kind of secluded, or a quieter neighborhood where you have better access to the sky and less light pollution everywhere at night, I'd recommend really taking some time, try to catch some meteors. Kind of cool. Okay, so today, or with this video, I just wanted to kind of walk you through an example of the assignment that you're doing today, which is looking at a graph that shows data and analyzing that graph and interpreting what that graph means. So I'm going to go through one example here, and then you have your own worksheet that has a graph that you'll be doing basically the same thing. Okay, so I'm looking at this graph. This graph is labeled ocean pH. And the first question I'm gonna try to answer is, I want to figure out what question is this graph trying to answer. What is the purpose of even having this graph? Because when scientists collect data, you don't just collect data for no reason. I mean, you could, but usually data is being collected because scientists have a question and they're trying to collect data to get an answer to that question. So the first thing I want to know to start making sense of this data is, what were they trying to figure out in the first place? What was the question that was being asked? So I'm going to look at a few things to give me some clues. The title, which says ocean pH. If I look at the axes of the graph, I have on my x-axis, which is the independent variable, we see time in the form of years. So over the past, past century, kind of looks like. And then I have two y-axes, so there's two dependent variables that are being measured. We have carbon dioxide on the left and pH on the right. So pH, is a form of is a measure of how acidic something is. It's kind of a measure of how many hydrogen ions you have in a solution. So based off of the title, ocean pH, and then carbon dioxide and pH is being measured over time in the context of an ocean. I'm going to say that the question that scientists were trying to answer is how is the pH in the ocean changing over time? It's just that straightforward. Like how is ocean pH changing over time or being changed over time? And they're probably measuring, if you wanted to even make a more elaborate question, since I see that they're measuring carbon dioxide on the other y-axis, maybe I could reform the question to say, how is carbon dioxide affecting the ocean pH over time? So how are changes in carbon dioxide causing changes in ocean pH over time? Something like that, right? You guys get as elaborate as you want. The next thing I want to know, now that I kind of know like what the scientists were trying to figure out from this data, now I'm going to actually look at the actual data. Like for the first question, I was just kind of looking on the outside of the graph, not really looking at the data yet. But now I'm going to look at the actual data to see what does the graph tell us as the answer. So we see 3 different things, right? We've got a kind of maroon colored data, and then dark blue, and then light blue, and then some black trend lines for each color. So there's a key at the top of the graph. So the maroon color is atmospheric carbon dioxide. So just a measure of how much carbon dioxide is in the air. And then the dark blue is seawater, partial pressure of carbon dioxide, and the units are micro ATM. So this is a measure of how much, basically partial pressure of carbon dioxide. That's just a measure of how much carbon dioxide is in the seawater. So how much carbon dioxide is being dissolved into the ocean. And then the light blue is a measure of seawater pH, so measuring the acidity of the seawater. And so I'm going to start from bottom to top. So the maroon color, we see that it's increasing. Over the last 50, 60-ish years. So what that tells me is that, especially if I'm looking at the left y-axis, and I see a positive trend line. So over the past 50 or 60 years, the amount of carbon dioxide in the atmosphere has increased. And then I'm looking now at the dark blue data, which is the pretty much a measure of how much carbon dioxide is being dissolved into the ocean, and that has a positive slope, right? So I'm seeing, even though the line is kind of like, but the trend line is positive. So what that tells me is that the amount of carbon dioxide that is dissolving into the ocean is increasing. More carbon dioxide is being found in the ocean surface. And then the last color data, the light blue, the seawater pH has a negative slope. So if I'm looking now at the right side of the graph, the right y-axis, in the past 10 years, 20 years for this graph anyway. It looks like the data stops around 2010-ish. The pH of the seawater decreased from about 8.011 to 8.08, so it dropped by like 0.03 pH. And so what this data is telling me as the answer to our original question, how is changing carbon dioxide affecting the pH of the ocean? Carbon dioxide is increasing, is one part of our answer. So carbon dioxide is increasing in the air and in the water. And the second part of our answer is the increase as carbon dioxide is increasing in the air. it's causing an increase of carbon dioxide in the water, and that increase in carbon dioxide in the water is causing a decrease in the pH of the ocean. So the ocean is getting more acidic as carbon dioxide is increasing in the atmosphere, if you want to tie that all together. So that's the answer that this data is telling me. This graph is a little more involved. There's a lot more, there's kind of, several things going on here. Your graph is not going to be as, data heavy. So don't worry, it's not going to be like this complicated. Now I want to know, because we've been talking about climate change this week, what does this data have to do with climate change? How is this information related to climate change? And it's related because we talked about how with climate change, we have an increase in the carbon dioxide that's in the atmosphere, and that excess carbon dioxide in the atmosphere is, it's a greenhouse gas, and it's trapping the energy from the sun, and it's not letting it escape from the earth. So then it's causing a gradual warming of the global temperatures. So carbon dioxide is a big player in when we're talking about climate change, and carbon dioxide is, the maroon color is measuring the increase of carbon dioxide in the atmosphere, and studying how it affects ocean pH is kind of just, measuring data about how, the many ways that an increase in carbon dioxide affects other parts of the world. So how does this increase in carbon dioxide that causes climate change, how does that negatively affect the oceans? And we see that the increase in carbon dioxide in the atmosphere, increase in this greenhouse gas, causes the oceans to become more acidic. And then, now that we've figured out, okay, this is how this relates to climate change, so what? Why does this matter? What does this have to, how is this going to impact life? Human life, but, just life of other species, life in general, the ecosystems, why should we care about this? Well, when the ocean becomes more acidic, and, it might seem like if you're looking at the axis for the pH on the right side of the graph, you might be thinking, it's such a small change in pH, 8.11 to 8.08. That's almost no change. Well, I can tell you that the pH of your blood in your body is very specific, and a drop in 0.2 pH in your blood is going to be so devastating to your body that you can get seizures, you can go into a coma. Your body could just start shutting down because your body cannot handle of that much of a change in pH, and that's just 0.2, right? So life is actually extremely, extremely sensitive to pH. I mean, there's some organisms that are quite tolerant to extreme living situations, but a lot of life is really sensitive to even really tiny changes in pH. So when the ocean is becoming more acidic, because carbon dioxide that dissolves into the ocean, it can react with water and form carbonic acid, and that just makes the ocean more acidic. Coral reefs cannot handle that increase in acidity, and as the ocean becomes more acidic, coral starts dying. So we are starting to lose our coral reefs. And when you lose your coral reefs, you lose the coral isn't there to be a habitat to support the huge diversity of our coral reef biomes. And furthermore, without coral reefs, healthy and thriving in place, they don't act as a natural flood barrier against intense waves and whatnot around the coasts that coral reefs are protecting, which will impact human life that lives in the humans that live near the Great Barrier Reef or other coral reefs around the world. They're losing natural protection as the coral reefs start dying. Any marine animals that need to have a shell around them, the the increased acidity, starts dissolving their shells. So now these animals won't have protection and they won't be able to survive as well. So then you'll start losing basically any organism that has a shell or uses a shell in their life. And so those are just like, a few of the ways that this increased acidity in the ocean pH can affect our life and the lives of other organisms that live in the ocean. And then you have one more question that you'd be answering on your worksheet, but I'm not going to answer it because I think it's pretty self-explanatory about how you would go about, figuring that out. I will just point out that the very bottom of my picture, I see something that says source, and it gives me a website link of where I could have found this data if I wanted to, see where this data is coming from and evaluate whether or not I think it's a, trustworthy data. Okay, so that's all I wanted to do with this video. Just kind of walk you through an example of analyzing a graph and interpreting it. I felt like there was something I was going to say, and I was saving it for the end, and now that I'm at the end, I just can't remember. Oh well. No, it's not coming to me. Okay, well, that's fine. Oh, no, I remember. Okay, so, Friday, you're gonna be, the assignment for Friday, or the activity for Friday is, I'm gonna be posting access to this movie called Before the Flood, and, it's about an hour and a half. If you can break it into half an hour segments if you want. That's actually what I did, because sometimes I have really low attention span. And basically for that movie, it's kind of like a movie about, human environmental impact and the ways that we've been affecting the environment. And what you're gonna do for that movie, I'll make a little worksheet thing, is I'm gonna ask you to, while you're watching it, pick, three claims that the narrator makes. I think the narrator is Leonardo DiCaprio, but like 3 claims about how humans are impacting the environment that are made in the movie. There's definitely more than 3, but I'm just keeping it at a very low. And I want you to find evidence that basically supports that claim. So basically, you're kind of playing a little bit of a skeptic, like, do I really believe that what you're saying is true? Like, this is actually happening in the world, and this is actually a big deal. So I want you to find data that backs up that claim. So you have the entire movie to find 3 claims that you either think it would be easy for you to find data to back that up, or I challenge you to pick 3 claims that you never knew, that was actually like new information to you for the first time. And so I think that it would be more interesting for you to find data that backs up this new information that you just heard in that movie. And then so that's what you'll be doing for a Friday. And it does say that there's a quiz. I have not written it. I have some like ideas floating around in my head about what I'm going to do with that, but don't worry too much about it. It's not going to be like a big deal or anything, or it's not going to be like crazy hard or whatnot. Okay, that's it. If you see any meteors, let me know. Comment below. Or if you do anything for Earth Day, also let me know. Yeah. All right. So have a nice Wednesday. Have a nice Earth Day. Spend some time contemplating nature. Okay. So Dinosaur and I are saying goodbye.